Good afternoon and welcome to the final day of BBC Rail Watch. I'm in the National Rail Museum at York at the moment, standing on a piece of BR history. It's an old Great Western Railway engine. But today we're not so much concerned with the past as the future. After a week in which we've seen British Rail, it appears, struggling at times to keep up with the 1980s, the question we ask today, in an era when the government is saying we must all use public transport more, what's it going to be like travelling by rail in the future? The Edwardian machinery has disappeared from British Rail, but we've discovered this week that it appears many of the working practices from that era still hang around. So today we put British Rail management on the spot and talk to them about the railways of the future. We show you the technology of the future with a sneak preview of a train for the year 2000, and we show you how to jack up a 1,350 metric ton cast iron bridge, just in case you've got one that you'd like to do the same trick to in your back garden. And we'll also be keeping in touch with what's happening around the country. The weather has affected many parts of the country today, with winter arriving for the first time. Yesterday we were in Leeds, remember that? We left them last night, but Penny Buston is there now to see how the rush hour went this morning. Penny.
Good afternoon from a rather chilly Leeds station. Well, it was a below-average rush hour this morning, I'm afraid, due mainly to mechanical breakdowns. They were left 3 or 4 trains short. That was mainly for local services, so 1 or 2 upset commuters there. The worst example was the 6:58 Hull service. There was engine failure on that. It was 43 minutes late while a replacement unit came from the depot. Now, it's also been trying to snow on us here this afternoon. David Thomas is the manager. Does that cause you any particular problems?
Yes, it does cause us an awful lot of problems, but despite the fact it's freezing cold here at the moment, the weather forecast is quite encouraging.
But you've got a bad weather plan?
Yes, we do have our winter preparedness plan, which means we've facilities to call people out to light point heaters and to shovel snow out of points at junctions and things.
Do they volunteer for that?
Yes, they're very good. They all rally round when things need doing.
And do you issue them with thermal underwear?
Yellow, actually.
That's the undercover story here from Leeds this afternoon. Back to Rob in control.
Thanks, Penny. Well, in spite of all the snow, things have been running pretty well today, actually, although they did find a broken rail this morning just near Doncaster. It's only a fairly small crack. The trains actually can run over it as long as they go at very slow speed. So what they did, the engineers asked if they could close the line for 3 hours this morning to make repairs, but the controller here said no, it caused too many delays. Now, that's a flagman who's been standing there all day. He looks pretty miserable. It's freezing cold. As well as waving the flags, they also put those detonators on the track that you've just seen. The train triggers those as he goes over, and the driver knows straight away that there's a hazard up ahead, so he slows down to 20 miles per hour. That's causing delays of about 5 minutes on the trains, which isn't too bad. If that break gets worse, then they'll divert the trains around the Ascot branch line, which will add about 20 or 30 minutes onto services, so you can see why the controller made that decision not to close down the line. They'll repair that track at midnight tonight. But of course, all week we've been following our own train, the Rail Watch Power Car, and our driver John Swaby. As far as the train is concerned, well, it's had a pretty hectic schedule since it was named on Monday morning. It did have a little problem on Wednesday, however, when it broke down, but it soon got back into service and is running very well now. Last night it spent at the Heaton Depot near Newcastle. It then took the 6:30 from Newcastle to Edinburgh train. Left Edinburgh just before 9 o'clock this morning for King's Cross, where it arrived 1 minute early. By then it had done 3,936 miles. Here's our last view of the BBC Television Rail Watch Power Car leaving York Station. Still looking quite clean, a few little dirty marks on it. By the end of today, it will travel the distance to the equator. Bye-bye to the Rail Watch Power Car. Well, our driver John Swaby will give you more information about him later on in the programme. But for now, let's go over to Bounds Green and Paul Coyer.
Thank you very much indeed, Rob. Well, Bounds Green near Alexandra Palace is the Intercity London Service and Heavy Maintenance Depot. And with me is Martin Cornwall, who's the branding manager. And it's important to stress we're wearing these safety vests because we're out on the tracks, right?
Indeed, that's essential, yes.
OK, now what I want to talk to you about, Martin, is basically the colour scheme, the livery as such. How many different colour schemes do you have on British Rail? Because I know that you used to have several.
Well, at the moment we have got in the region of 8. But we are in the process now of rationalising that down to 4.
And what would the 4 be then?
Well, we've got the Intercity livery, which is featured on all the Intercity trains purely on passenger services. And then we come on to the rail freight livery.
Which is the train that we have nearest us here, the engine there. Right.
This one shows the blue and yellow wavy lines depicting the petroleum subsector. And in addition to that, there are 4 other subsectors, each having a symbol depicting their operations. And that's coal, metals, construction, and distribution.
The one next door to it then, again, we've got a different colour scheme, different livery. What is that used for?
This is for locomotives used on frontline passenger services, and it's for locomotives which are shared between the various businesses such as Intercity and Parcels, and it appears in that livery to prevent confusion when used with the trains.
All right, well, you said 4, so we get one more to come. It's the one at the far end. What is that?
The final one is a general user category and is BR General. This is for departments such as the civil engineer who maintains the tracks, and for any other usage not involving passenger operations.
OK, well, you mentioned Intercity. We want to show the Intercity off. We didn't just want to show it on any old train. We're going to show the train of the future, the new Class 91, and it should be coming through the doors right now. Martin, that you have reverted to the pantograph. We're back to the electric train, aren't we?
Indeed, yes. The idea here is that it will be cheaper to operate and cleaner, and the electric system on the East Coast Main Line, where this will operate, is due to be completed by 1991, when we will have operating speeds of up to 140 miles an hour.
And that little cheeky face hanging out the door there, we wonder where you'd got to, is John Swaby, our adopted driver. Give us a wave, John, go on. How you doing? You all right?
Fine, lovely.
OK, well, we'll be coming back to you later, John, to explain a little bit about the workings of the train. OK, thanks very much indeed. Now, Martin, obviously you're working for British Rail. You're as enthusiastic as anyone else about this, but do you really think it's a step for the future? Or are we still marking time a bit? Do you think this is going to really take us into the future?
I think this will take us into the future. This is very important. Here, Intercity and Rail Freight are identifying themselves very strongly with their customers, and that's important. And it's important not to have any confusion as far as locomotives are used on the railways.
Just very, very briefly, why do you think it's important to have these different colours at all? I mean, you talk about customer identification and things, but there must be more to it than that.
No, it's very important that the customer relates to the locomotives that are operating on their business. The customer for Intercity can relate very much with this livery we see here.
OK, well, Martin, thank you very much indeed for explaining that to us. Now, we'll be coming back later to Bounds Green and finding out the workings of this, but we leave you there with the train that is going to take us into the 21st century. From Bounds Green, it's back to York and Mike.
So that's the new Class 91 or Electra locomotives at Bounds Green in London. But those 91s will eventually have a new generation of coaches as well. The first of them is already running past us here at York most days. It's marshalled in the centre of a short test train, and it has a high-speed train power car front and back. Now, one thing to look for is that, like the Class 91 loco, the sides of the coach slope inwards. That would allow a tilting mechanism to be added, and the coach is used as very high-speed trains on the West Coast Main Line. There's a new design of bogie to give a smooth ride up to 140 miles an hour, and the wires you see connect with the third coach. It's a test coach, more about that coming up later. This first production Mark IV coach is in fact the only one running and is doing riding tests to see if it meets its specification. Well, since the go-ahead for the electrification of the East Coast Main Line was given 4 years ago, progress has been swift on what is Britain's longest construction site. The line from London to Leeds is now fully electrified, and the first electric train ran into Leeds in August last year. Work now well in hand on the programme to complete the Doncaster to Edinburgh section. That's due to be finished in May 1991, just over 2 years away. Railwatch has been out and about to see some of the complexities of the work involved.
As well as being enormously costly, the logistical problems of electrifying the East Coast Main Line are staggering. The Doncaster East Coast Electrification Depot is where some of the problems are tackled. Here is based a staff of over 200 who maintain what appears to be a vast builder's yard, gathering and loading all the raw materials necessary for the project. To get to the site, everything first has to be loaded onto a train, including the steel support masts, clips, cables and insulators, as well as the concrete and aggregates needed to complete the foundations. The concrete mixer, like everything else, is mounted on a train. Making sense of what appears to be little more than spaghetti when laid out on the ground is Charles Batty's job.
The depot is used for the cost-effective assembly of items of equipment and support assemblies and the storage and delivery of mass per site. In the depot we manufacture the cantilevers and the headspans. These are the frames and the wires which support the overhead equipment, and you will currently see the headspands being manufactured on a jig in the depot which simulates site conditions.
Out on the track, the work is done in stages. The first step is to put up the steel posts. Here, the civil engineers are using a new device specially designed for this project that vibrates the post's foundations into the ground. It's faster than the old method and cheaper too. The masts are then erected, different configurations being required according to the demands of local geography. Once these are in and the headspans are in place, the wiring trains arrive. These operations must take place during planned possessions, that is, when the line is free of traffic as agreed in advance. The pressure is always on to minimize this, avoiding the disruption of revenue-earning movements. The electrification program has not been without its special problems. Some months ago, special lightweight steelwork went up on the Royal Border Bridge at Berwick. Special because of a desire to make the necessary structure as visually unobtrusive as possible. The same special attention was given to the overhead assembly running through York Station. The Royal Border Bridge and York are just two of British Rail's thousands of Grade 1 listed buildings, and the design of the assemblies had to be scrutinised by the Royal Fine Art Commission. Once all the elements of the overhead are in place, the fine-tuning starts. The connections are checked, and the stagger of the lines relative to the track is checked with a hand gauge. Before the section becomes operational, a pantograph train is then run across the completed assembly to confirm that the system works at speed.
From Newark to Leeds is now energised, and they are running test trains over the section line. I am currently my contractor is currently working on some 365 single-track kilometres of railway from Doncaster to Northallerton.
Paving the way for the new Class 91 locomotives that will soon run the full length of the East Coast Main Line.
Rob Curling on the round-the-clock work going on to complete the electrification of this main line to Edinburgh. One thing we didn't see in that report was the problem of bridges that might well be high enough now for the trains to pass underneath, but are too low for the overhead wires as well. So some have to be rebuilt, but others, like this one next to us, it's the Holgate Bridge just next to us at York, they're quite simply lifted up to give the extra headroom. It's 2 o'clock in the morning on Sunday the 29th of January. After several weeks of careful preparations and with portable generators providing the lighting and power run-up, British Rail's contractors are ready for the crucial lifting.
The bridge is about 80 years old and is in very good condition, so there was no real need to replace it. Raising it by jacking up is the cheapest option available to us to provide the clearances. The other options, such as lowering the track, were complicated by the fact that the ground conditions in this area are not very good. We would also have had severe difficulties in lowering the track and maintaining traffic. There are 12 jacks lifting the bridge simultaneously. They're arranged in groups of 3, approximately at each corner of the bridge. When the system comes into operation, all of the jacks will operate together to lift the bridge as one unit to make sure that we don't damage it during the lift. We're lifting the bridge a total of 300 millimetres. It's done in 3 100 millimetre stages, and all told it's going to take somewhere between 3 and 4 hours, all going well.
Despite some anxious moments, the operation goes smoothly, and by the end of the night, 1,350 tonnes of bridge is sitting securely in its new position. And the job of resurfacing the road is also nearly completed. Next week, after the PBC's moved out of here, the work will start on the tracks running beneath the bridge. And with the track modernised and the overhead wires installed, the final important ingredient in a newly electrified line is, of course, a fleet of new trains. So let's now go back to Bounds Green in North London, join Paul Coyer live for a closer look at those new Class 91 locomotives. Paul.
Thanks very much indeed, Mike. Well, standing this close, you can see just how magnificent this beast is. There are 10 of them in existence at the moment, and on a good day, you can maybe see 5 or 6 of them out being tested on the track. Well, earlier today, I had a guide who took me round this magnificent engine, and it was David Rowlands, who is the project coordinator. Well, David, it's now 4 years since you sat down without a clue what to do, but what brief had you been given?
My boss, the director of Intercity, said, I'm spending £306 million electrifying the East Coast Main Line. I want 31 sets of traction and rolling stock. I want them by May 1991 at the latest, and also I want some for the lead service in October of '89.
But presumably you then have to talk to your other colleagues in British Rail to find out what they want out of it.
Absolutely essential, yes. We produce a business specification. Although it's the Intercity's aspirations as such, you must consult with all the colleagues that you've seen all this week.
It looks good too. I mean, the enthusiasts who call this Electra must be happy that, for instance, the buffers are back on the old trains again, eh?
That's right. This gives us flexibility in operations. Some people like them, some people think we should have the long snout of the TGV. We took a balanced view on this. I think it's a very majestic looking beast.
It certainly is, but of course it was built not by British Rail engineers, which traditionally the engines had been up until now. Why did you hand it outside?
Essentially because British Railways Board are in the business of moving people and return on assets on that. Industry knows best about designing and manufacturing products.
Does it make it more expensive?
No, it shouldn't. It's a question of managing these people. The more they can get, the better, but it's up to us to keep control. The main thing is to make sure they meet the performance specifications.
So how much is this going to cost?
These beasts cost £35 million for 31, which might seem a lot to you, but it's quite competitive.
Well, let's go and find out just how it works. We'll look at the bits and bobs underneath and find out how it differs from the traditional high-speed train. Now, David, you said that you were hoping to have eventually 31 sets. What exactly makes up a set?
The set consists of a Class 91 locomotive at one end, some coaches between, and at the other end, a novel idea of a driving van trailer.
What exactly is that?
It's a machine that looks very much like this from the outside, but there's no equipment inside it. It's a parcels van.
So you've effectively only got one engine which is doing a kind of push-pull role. What happens then if that breaks down? Because with the diesel high-speed trains, you said at least we get 2 engines. If one breaks down, there's another one to do the job.
It's a question of risk. You must remember that the number of moving parts between the overhead, the fuel, which is the overhead wire, and the drive motors here, there's far fewer moving parts in here. And of course, we have 2 circuits for the traction. If one breaks down, we have the other one to fall back on.
So once the power reaches the transformer, once the electricity gets there, what actually happens after that?
From the transformer, it goes through a big box of electronics where it's converted into DC, and it drives a DC traction motor. But there is one fundamental difference between this product and the other one, is that the traction motor is mounted solid up to the body. This is to reduce the mass of the wheel set, which is the principal cause of damage to the track.
Now, this is all very good and great, and it looks terrific, but of course the last time you lot blew your fanfare trumpets was for the APT, which was a failure, wasn't it? But have you learned anything from that?
Oh, absolutely. It wasn't total failure. Your knowledge is never lost, and we've incorporated a lot of that knowledge in the performance specification for this beast.
The final question then, when am I going to be able to see this wonderful train down at my local station?
Well, officially you're going to see the complete train in October of '89, which is what we set 4 years ago. But if I can perhaps let you into secret, as long as you promise not to tell anybody.
I promise.
You may well see the Class 91 in public service next month.
Oh, I look forward to that. Maybe I can have a shot on it then. Can I do my schoolboy bit now and go into the cab here? Because I'm dying to see what it looks like. Well, that's how the engine differs outside, but what about in the driver's cockpit here? Well, John Swaby's going to guide me through that. So, John, how does it differ up here?
Well, it differs up here from the high-speed train because we're in the high-speed train, we sit in the centre of the cab. We've now reverted to sitting on the left-hand side like the old locos. And we also sit up a little higher because of the greater speeds.
Very much like a car, you have a cruise control now, don't you?
Yes, we do here. Whatever the track speed we are running on, we set the indicator and the computer gives us whatever power to reach that speed and brakes so we don't exceed the speed.
You also have a radio, I notice.
Yes, we have a radio now built in on the console which picks up any British Rail internal number from the cab.
Very handy, obviously. But what sort of training did you have to do to be able to work this?
We had a fortnight's training, 1 week in the classroom, then 1 week out learning the driving technique on the new traction, and then we had an exam on the last 2 days.
So you have a computer as well now, I gather. How do you feel about that?
Yes, we have a computer, which is good because if a fault develops, we get a fault light on the desk and the computer will rectify it when we press the reset button. You're allowed 2 resets, and then if it doesn't reset, you have to go in and find out for yourself what is wrong in the engine room.
Great. Well, you're obviously very happy with this. This is the latest state of the art, and from here at Bounds Green, it's now back to York and Mike.
Well, something there of what's involved in preparing for the new electric services, which should start running as far as Doncaster and Leeds this May. But let's leave our look forward for just a few moments and go to Rob Curling, who's been digging up some amazing facts about the past at the National Railway Museum here in York.
With all this enthusiastic talk of modernisation and electrification, there are a number of exhibits here at the National Railway Museum to remind us that the idea of electric railways is actually a lot older than you might think. Now, this electric locomotive was in fact built as long ago as 1904. In Newcastle, the North Eastern Railway had to work coal trains over a line that included a curved and steeply graded tunnel. Now, steam engines working hard with heavy loads caused unbearably asphyxiating conditions for the footplate crew. Well, the answer lay in the new technology of the day, and this was the result. And 2 of these locomotives worked the line until the 1950s. The Southern Railway started to electrify its commuter lines into London before the First World War. The scheme began in earnest in 1923, which is when this motor coach was introduced. But of course, the Underground Railways, particularly the deep tube lines in London, had adopted electrification even earlier. But soon, railway engineers were thinking about the benefits to be had from electrifying main lines. Again, the North Eastern Railway was in the forefront. And in 1922, as part of a scheme to electrify the East Coast main line between York and Newcastle, built and tested a mainline express engine. This is a model of it. The scheme never went ahead, but for 40 years, this locomotive made occasional runs on a line between Newport and Shildon in County Durham that had been electrified. It wasn't until after the war that the first true mainline electrification scheme was completed. The Woodhead tunnel route between Manchester and Sheffield, which used locomotives like this one to haul both passenger and heavy freight trains. And later still came electrification of the London to Birmingham and Manchester line. But why electrification in the first place? Well, the name of the game is efficiency, and an electric locomotive is far more efficient than a steam engine or diesel. What's more, an electric locomotive doesn't have to carry all its fuel about with it. That's left behind at the power station. The energy needed to work the train is supplied by the overhead wire, and the engine can draw effectively as much power as it needs. And if it hadn't been for the economic circumstances of the time, perhaps the East Coast main line would have been electrified long before now.
I keep seeing things I used to have on my model railway at home. I must be very old. Rob Curling at home in the past there at the National Railway Museum. Here in York, you must visit that place if you come to York. The electrification programme also gives the civil engineers of British Rail a great opportunity to modernise the track layout. And they're just about to start a major programme of track relaying just beside us here at the south end of York Station, rationalising and simplifying the layout to be better suited to the needs of the modern railway. Well, as well as that, there's a regular programme of replacement to keep the existing track in top condition. And much of that work takes place when it causes the least disruption to services. That means overnight and at weekends.
It's midnight near Tollerton on the East Coast main line just north of York. And this is what they're doing to the Down Fast track. Cut up into 60-foot lengths, the old track will be taken away by train for second-hand use on a less glamorous and less busy route. In its place, before the night is out, will be brand new track.
So tonight we're laying approximately 750 yards of track. That's a normal amount of track to do a one night. We're doing this for about 3 weekends. So this is the first of 3, and we'll continue onwards. Hopefully we shall finish the work at 6 o'clock Monday morning, handing back 125 mile an hour.
Running on rails specially placed on the stone ballast beside the track before it was lifted, the single-line gantry returns from the relaying train with a batch of new sleepers. A steel rail of the main line is heavy and it gets a hammering from the high-speed trains, so sleepers are now made of reinforced concrete. Not all work involves sophisticated machines. For positioning the sleepers, there's still nothing to beat a wooden template and a couple of blokes with crowbars. Resilient pads go down where the rails will sit on the sleepers, and along comes the next gang with a crafty little device called a carping machine. It lifts the rails that the gantry ran on and pulls them in to sit in their proper place on the chairs of the sleeper. Another gang and more muscle power to clip the rails in place. While up the track a bit, the welders are having what at first sight looks like a firework party. But this is serious business, welding 2 lengths of rail together to form the continuous welded track.
This is what they call the thermit welding, which is done with the thermit mixture.
The manganese and alumina powder in the crucible burns with a fierce heat, and the white-hot melt runs into a tiny gap left between the rail ends and forms a tough and durable weld.
The stripping is 1 minute from it dropping to taking the crucible off, 2 minutes for taking the slag basins away, 3 minutes they will take the saddle away, 4 minutes take the shoes away, then 5 minutes they will start going in with the trimmer to trim the existing top, and that will then be ready the same as this one is here.
With the weld set and the rail profile ground, next along is the ballast cleaner. An endless chain underneath the track that the machine is running on scoops the old ballast into the mechanical innards. From there, the unwanted mud and broken stone is dumped into waiting trucks on the next line. The remaining ballast, freshly cleaned, is put back where it came from. There'll be more machines along before the trains can run again on Monday, but for those whose working life is spent out in the open while we sleep soundly in our beds, has this been a typical night?
Tonight it's very mild, we're very lucky, a little bit of frost, no wind, extremely good weather. Sometimes though it can be a little bit bad, wind, rain, howling rain, but it doesn't matter, the job continues, we just carry on until the job finishes, and that's it, you know, nothing stops us.
It'll be daylight before this machine gets to Tollerton. It's a new device, the Dynamic Track Stabiliser, and British Rail are very proud of it. It mechanically compacts the ballast to give a firm support to the sleepers, otherwise it won't be safe to run trains over it at speed. Until now, the trains were made to slow down for a week or so, using their own weight to settle the ballast. Now it's done in a few hours. And come Monday morning, the 125s will run flat out, eliminating those infuriating speed restrictions and helping to keep the service run to time.
And imagine what it's like trying to do all that work in the snow that we had last night. Well, so far we've been talking about the immediate future of the East Coast Main Line, but elsewhere in the British Rail corporate structure, there are some people who are looking further ahead to the mid and the long-term future. They're concerned with the shape of the railway in the 21st century. Foremost amongst them are the scientists and the engineers of British Rail's Technical Centre at Derby.
British Rail has its own research division based at Derby. Here, behind the day-to-day running of the railway, it researches new ideas and uses modern methods such as computer-aided design to look into every aspect of railway engineering.
The main areas of research are into vehicles, structure and control. And on this site we have very extensive laboratories which enable us to do testing of vehicles full scale, of vehicle structures, sections of track, and develop the electronic systems for control. And then nearby we have test tracks, and of course we have access to the real railway.
Developments in computers have allowed the creation of the Integrated Electronic Control Centre, which employs a special program capable of controlling signalling in the face of service alterations, automatically calculating the most efficient way of returning to the schedule. This system will be installed at Liverpool Street over Easter and subsequently at York, replacing large multi-panelled mimics with a few VDUs. Down the road at Mickleover, at the end of a piece of the division's test track, is the Aerodynamics Laboratory. The high-speed trains of the future will bring their own peculiar problems, and the scientists here have built a unique model test track to find out how trains behave as they pass each other at speed. It can also provide information about trains running through tunnels, which may prove useful to more than one future project. This rig is not as high-tech as it may seem to the casual observer, as it's based on a series of large-diameter elastic bands. Just before the model is fired at high speed, the area is cleared of all personnel.
The main interest in this sort of investigation is to look at the magnitude of the pressure pulses which are generated when trains pass one another. The pressure pulse is often felt by passengers as a train passes, as a jolt or even a pressure sensation on the ears. And the means for minimising the magnitude of the pressure pulse are to increase the track spacing or to increase the length of the train noses. But one can only gain a certain amount from increasing the length of the noses. There comes a point where one is on the law of diminishing returns. We may see trains having noses as long as 4 metres, but there is always the difficulty of accommodating long-nosed trains on curves.
Research at Derby has continued for over 20 years, as the prototype HST shows. But this converted buffet car, Argus, allows investigation to be carried out on the move.
The purpose of the coach is to sit within a test train and collect data from it. And the test train can be anything from a low-speed freight test to a high-speed passenger train going up to 150 miles an hour. The data is brought in from outside the vehicle and is brought on cables to an internal patch panel. And from there the signals are fed to amplifiers where they are raised in levels sufficient to drive recorders and the computing outputs. The recorder here will record 42 channels of data real time. Data can also be brought out onto paper recorders where the engineer can see during the test what has happened to each of the channels. We can handle up to 60 channels at a time. For the convenience of giving the information to the engineer in a better form, we have a computer on board which enables the engineer to see in real time what is happening to the test. So here we see a display which is available to the test engineer. This can be running during the test and giving him information. It can also feed information to the computer where it will be analysed and recorded for future use. We can take signals from the running tests and also feed them out into paper printed plots at the back.
So, as the new technologies of the 21st century merge with the best of the existing ones, the railways will continue to evolve to meet the changing demands of the future.
Thanks, Rob. More of the future to come soon, as they say, but let me just now deal with the present. We have with us two gentlemen from British Rail to put some questions to them after our week-long rail watch. On the right is Colin McKeever, Regional Operations Manager, and John Nelson, General Manager of Eastern Region. Has this been a typical Eastern Region week that we have observed?
Well, I'm not sure, Mike, there's any such thing as a typical week, but what I think has come across in Rail Watch is a very good portrayal of the complexities of running a railway on a day-to-day basis, and I think that has come across very well during the week. I think some of the particular incidents that have come up during the week you couldn't really classify as typical in themselves, but obviously managing incidents on a real-time basis is very much part and parcel of running a railway, and to that extent, yes, I think it has been pretty typical.
Our own Rail Watch train does appear to have broken down rather a lot. Now, I understand that that train has just gone through a major overhaul and it's only just shortly come out of the workshops, just recently come out of the workshops. Why should it break down so much?
Well, I'm not sure that it is broken down on that great a frequency, but one of the problems that we do...
Twice in the first 3 days of its life with us.
Yeah, I wasn't aware that it had broken down twice during that time, but certainly problems of a mechanical nature with our high-speed trains, which are now between 10 and 12 years old, do arise on a fair frequency. And of course this is one of the principal reasons for electrification of the East Coast Main Line, to replace this rolling stock.
Surely the solution to this would be to have more high-speed train rolling stock, and then you wouldn't need to have all this maintenance going on all the time.
Well, there are two tacks on that. First of all, the investment in electrification that is taking place will in itself do a great deal to improve the reliability of our traction and rolling stock on the East Coast Main Line. In the meantime, while we're still working on it, we have a number of initiatives currently in hand which will improve the availability of the number of power cars in operation. For example, at Neville Hill, which you've been looking at during the week, we are putting in some additional craneage facilities within the next 2 months, which will enable that depot to improve its output of high-speed train power cars for the May timetable.
Right. Colin, £306 million being spent on this East Coast Main Line electrification scheme. Is that going to divert funds away from the crucial for the passenger provincial routes?
No. Most provincial passengers are now travelling on trains which are less than 4-year-old. BR's investment programme over the next few years is £3.8 billion. A lot of that is going into new units on the provincial routes, many of which you were seeing in the Leeds area. The Trans-Pennine routes are being fitted out with new trains. The customers are going to benefit very quickly and over the next few years.
I'm going to put to you now some rather old eggs that we picked up this week, but it's the same old complaints from people. First of all, your trains are dirty, and we're not referring so much to litter that's dropped by people, but the grime that's on the inside of the windows, and you put your sleeve up on the window and you get a black mark on it. Trains are dirty, they're late, and they're overcrowded. At Leeds, there were big problems with overcrowding on the provincial services. What can be done about all that?
Well, can I perhaps first of all deal with punctuality, which is the most important aspect of running any railway. I think one of the things that hasn't come across this week is the extent to which we do run a punctual railway. Now, for example, in West Yorkshire, which you concentrated on in terms of local services, we're currently running at a level of something like 95% of our trains arriving within 5 minutes, and a very low level of cancellation.
But isn't it a case that the 5% that's late tend to be in the peak periods affecting most people?
Not necessarily, so no, but our peak arrivals in the Leeds area are currently running at the level of 90% right time and 95% within 5 minutes of time. If you look at our commuter services in the London area, we have a very, very good record there. On some days we're running 100% at that level of reliability. So it really depends on where you focus, but generally speaking our punctuality is of a high level.
All right, what about cleanliness?
Well, cleanliness too, we've been investing a lot in equipment to clean our trains both externally and internally, and I don't think that I would accept as a general statement that our standards of cleanliness are of a low level.
So you're happy about running your finger around the inside of a provincial train window and it coming out black, are you?
No, of course I'm not, and I'm not wishing to sound complacent. But what we are doing at the moment is putting an awful lot of effort into not only investment in equipment to improve our cleanliness, but also into staffing.
You see, I have to put these points to you because they're points that are raised with us in the coverage of the programme. For instance, a woman rang in. Now, she's disabled, and she travelled, not necessarily on your region, but it was on British Rail. She travelled from Cornwall to Scotland, and she could not use the toilets on the train. She had to use a bedpan on the train to go to the toilet. She could not use your toilets. Now, this is 1989, and we still do not have disabled toilets throughout British Rail, and yet disabled people will make more use of British Rail than able-bodied people because of the state they're in.
Well, it's very disappointing to hear that particular tale. But on the general level, what I can say again is that with our new rolling stock, we are investing an awful lot now for the disabled. And the toilets on our new intercity rolling stock and much of our provincial stock will be of a standard which will enable them to be used by disabled people. And can I just say that we do have, as a national network, a very good system for disabled people to travel around, particularly those in wheelchairs. And most of our mainline stations now, we do have facilities specifically for disabled people. We're investing a lot of money in them, and we do have arrangements which will enable disabled people to travel from one part of the network to another with assistance offered en route.
And so you can categorically state that disabled people in wheelchairs do not have to travel in the guard's car any longer?
In the vast majority of cases, they do not, certainly on intercity trains.
Right. One final question on this. Let's leave on a positive note if we can. We're looking towards the future in this programme. The government is urging us all to make more use of public transport. Are we going to have a British Rail in the future that is going to be able to take the strain? Because it is under strain at the moment, there is no doubt about that. It is pressed to big overcrowding at times.
Well, I think Colin has already made the point about investment. We're investing more now in the future of British Rail than for any other time for the last 30 years. £3.8 billion over the next 5 years going into British Rail. Now, this is going to make British Rail a far more attractive proposition to our customers, and it's going to enable larger numbers of people to travel by rail because of the investment going into it.
But is it going to mean less crowding or more crowding if we encourage more people to travel on the train? Will you have the rolling stock and the services to cope with it?
We believe that we will, yes.
Good. On that note, we shall leave it. And we'll go back to the future now, as they say in the movies. Paul Coy is waiting for us at Bounds Green with some more on those Class 91s. Paul.
Well, Mike, in fact, that's it from me, because it's the end of my involvement with Rail Watch. I've thoroughly enjoyed it, from Doncaster in the north down here to London in the south. It's been terrific fun. John Swaby, our driver, you've had a good week too. Have you enjoyed it?
Very, very enjoyable. If the public's enjoyed it as much as me, they've had a good week.
All right. Well, rather than us saying bye-bye formally, let's get the trains to do it on our behalf. Let's cover our ears and say, trains, off you go.
Stage struck, aren't
we? We're deafened here. John, do you have to work with that all the time, eh?
Only in the cab.
Good grief. I tell you. Well, from a very deafened crew here at Bounds Green, we'll leave you with one last look at the Class 91. And remember, if all goes well, you could see this on your local track trying out within the next month.
That was the train of tomorrow. This is the train of the day after tomorrow. A full-scale mock-up of the front end of the new international trains that'll run between London, Paris and Brussels through the Channel Tunnel when that opens in the mid-1990s. That brings us to the end of Rail Watch. Our many thanks to everybody at British Rail who's helped us. They will carry on working long after we've gone. We've been much taken by the people who work on the ground here. They are obviously hard-working and very dedicated, and very tolerant too. Think how you'd feel if somebody was following you around with a camera at work all week. But British Rail, what of the future? Well, it's a nationalised industry at the moment. It's perhaps gone through a period where nobody cares too much about it during the past 25 years. Privatisation coming up in the future? I think that's probably a subject for a different programme, don't you? Goodbye from the team on Rail Watch, Penny Bustin and Rob Curling and Paul Coyer and Malcolm McCaig. But I think we'll leave Malcolm asleep, shall we? Thank you for watching Rail Watch. A very goodbye to you from all the team here. Bye-bye.